right, welcome back. This is Unit 2.2, Classification of Matter, and this is going to be pages 40 through 42 in your book. Please read those. All right, so we used this same picture in the previous video, but we're going to use it again to talk about classifying matter. We naturally classify things all around us into categories. For example, in biology, you probably studied about taxonomy and the fact that biologists classify every living organism into kingdoms, phylums, class, order, family, genus, and species. Well, if we look at this same picture, these are classified as well. We talked about before in the other video properties. Well, I classified these in 3 different sections on this slide because of their properties. Well, this one is just one picture, but it's all classified according to red, the property of color. This one's classified because of the property of salty snacks. So I put all of those together in the center. And all of these are classified because they're heavy, and so they're over here on the right-hand side. So we classify things all the time. The main or the official way to classify matter is into pure substances and mixtures. So they're classified into 2 broad main categories, pure substances or mixtures. And then for pure substances, they're classified further into elements or compounds. An element is anything that's on the periodic table. So I have the example here of helium. And then a pure compound will be something like sugar, where it has carbon, hydrogen, and oxygen in a certain ratio of those elements. And so that is a pure compound. So go ahead and pause and make sure that you have this copied down into your notes. Okay, and so here we have a table where we have the operational definitions and conceptual definitions. Now, the difference in these 2 definitions is an operational definition is a type of definition that we'd use. It's unofficial. We would use it in just everyday, goings-ons. And then the conceptual definition is like an official definition of something. All right, so we have pure substances, mixtures, elements, and compounds. So go ahead and write this table down with all this information. All right, so for pure substances, all samples have the same proportions of components, a material with only one set of properties. Okay, so that's going to be a material with atoms that are chemically combined in a fixed ratio. So that's like sugar. And a material which in the solid phase has only one pattern and or a grouping of atoms throughout. Okay, so solid phase, that could be like sugar or like a sugar cube or a clump of sugar or actually a big crystal of sugar. Okay, as opposed to a mixture, which is a material with components that retain their individual identities, but it can be separated out. So this is like trail mix. Trail mix is a mixture. A salad is a mixture. Okay, the tomatoes have a certain property and components, and the lettuce has certain properties and components. It's mixed into a salad, but we can take those materials and separate them out. So it's a material composed of more than one substance. An element is a pure substance that cannot be decomposed. So on the periodic table. So if you see it on the periodic table, then it is an element, and it can't be decomposed any smaller than an element. Okay, so the conceptual definition of pure substance composed of only one type of atom. Okay, only one type of atom. And a compound is a pure substance that can be decomposed. So we can decompose sugar into carbon, hydrogen, and oxygen. Okay, a pure substance composed of more than one type of atom, carbon, hydrogen, and oxygen, is a compound. Okay, so we're going to talk a little bit about the periodic table. The periodic table is classified into a lot of different categories, a lot of different ways. The first main way that we're going to talk about the periodic table being separated and classified is metals and nonmetals. So if we look at this stair-step region right here under boron, and then it stair-steps down, This separates the metals from the nonmetals. So most of the elements on the periodic table are considered elements. So it's everything on this left-hand side. And we need to write down some properties of metals. Metals are good conductors. They're malleable. And you probably went over these in junior high, but we're going over them again. Malleable means you can take a hammer and you can hammer it into thin sheets. Ductile is another property of metals. Ductile means that it can be drawn into a wire. So you can stretch metals into thin wires. Metals are also lustrous, which means that they're shiny when they're polished. Sonorous means that they ring out. They have this ringing noise, like cymbals are made out of metal because they're sonorous. And most pure metals are really, really soft. You can usually scratch them with your fingernail or your teeth. So say here, for example, gold. Now, normally the gold that we have for our jewelry is not pure gold. It's not 24 karat gold. It's usually 10 or 12 karat, or maybe even lower percentage of gold. But, you think about back in the day when people would give gold to pirates. What's the first thing a pirate would do with a gold coin? Stick it in his mouth and bite it. Now, he wasn't tasting it. What he was doing was trying to see if it was pure gold, because on a pure gold coin, you can put it in your mouth and bite it and look, and you're going to see your teeth prints in the gold. Okay, so that would let you know that that was a pure gold coin and he wasn't being cheated. Okay, now everything on the right-hand side of this stair step, where we're talking about boron on down and over here, these are all nonmetals. So there's not very many nonmetals on the periodic table. Properties of nonmetals, they're poor conductors. Most of them are gaseous at room temperature. Okay, so we see here nitrogen, all of the ones that are red are gas. And they're solids. If they're solids, they're brittle. So they're not soft like metals. They're very brittle. So if you were to hit it with a hammer, it's not going to, like a metal, it's not going to make thin sheets. If you hit it with a hammer, it's going to bust up into tiny little parts. All right, and so you see this periodic table is separated into a lot of colors. Like this first group here is called the alkali metals. The second group is the alkaline earth metals. We have a group here that's pink. These are the transition metals. Okay, and then we have the lanthanides and actinides down here at the bottom in orange and a lighter pink. Okay, these light blue ones here, these are called inner transition metals or post-transition metals. And then we have some metals here that are either above, it's touching this stair-step line. So a lot of these that are touching the stair-step line here are called metalloids because they have properties of both metals and nonmetals. It's like the transition line between metals and nonmetals. But technically, if it's on the left side of this stair-step, it's technically a metal. And on the right-hand side of this stair-step, it's technically a nonmetal. And then we have here this light green. These are the non-reactive metals. Reactive metals. And then here the purple, that's the noble gases. So we also can see that it's separated solid, liquids, and gases at room temperature. So all of the symbols that are in black are solids at room temperature. There's only two elements that are liquid at room temperature, and that's mercury and bromine. And then we have some that are gases at room temperature, and those are the ones here that are written in red. Okay, so there's a lot of different ways to classify elements that are on the periodic table. But just to reiterate, our first way that we're going to talk about these is metals and nonmetals. Metals to the left, nonmetals to the right of this stair step. That's very important to remember. All right, so let's talk about mixtures. So if we go back a few slides here, we saw that all matter is classified as pure substances and mixtures. And we've talked about pure substances a lot here, elements and compounds. Now we're going to talk about the mixtures. So mixtures are also classified into two categories, homogeneous and heterogeneous mixtures. And if we think back to biology, the prefix homo means the same. So when you were talking about homozygous alleles during genetics, those are like alleles that have the same letters, like capital M, or lowercase m. Okay, so they were the same alleles. Heterozygous or hetero, the prefix means different. So that would be an allele that had like a capital M and a lowercase m. They were different. Well, those same prefixes mean the same thing in mixtures. So a homogeneous mixture, here, make sure you have this table written down, is a mixture that appears to be the same throughout. So examples of that would be like Kool-Aid, soda. So we know that Kool-Aid and soda are made of a lot of things like sugar, flavoring, molecules, things like that. But when we look at it, we don't see the sugar, we don't see the flavoring molecules. So they appear to be the same throughout the whole entire mixture. Whereas a heterozygous mixture, it's a mixture that doesn't appear to be the same throughout. So we're looking at things like trail mix, and we're looking at things that can be separated out. So the conceptual definition of those are the individual particles are smaller than 1 micrometer. So that's why we can't pick those things out. Like we can't pick out the sugar molecules or the flavoring molecules because those molecules are so small that we can't pick them out. Whereas in a heterozygous, these are particles that are larger than a micrometer. Okay, so those are the definitions. And homozygous is also separated out into solutions and colloids. So what is the difference between a solution and a colloid? Well, the difference between these is really easy to understand. In a colloid, the suspended particles are between 1 nanometer and 1 micrometer. So they're really, really small, but the mixture looks cloudy. And so the best way to tell the difference is to shine a beam of light through it like a laser. We can see here a picture. This is a solution. So if we look at this, we don't see a beam of light. The light's going through because we can see it here, but we don't actually see the beam of light. So if we were to take and put like a spoon of milk into this water, then these particles that make up milk are suspended in here, and they're big enough that they actually the beam of light hits them, and you can see the beam of light going through. So this would be a colloid, and this would not. This would just be a solution. Okay, so that is the difference between a colloid and a solution. All right, so that's it for this video. Please make sure you slap that like button right across the face. Give me a thumbs up and subscribe.